Hi everyone. So today I'm going to show you how to perform xgboost machine learning technique using R. So this xgboost algorithm or this machine learning technique is one of the variant of the boosting techniques. You might have heard about gradient boosting and adder boost. So this xgboost is also a variant of this boosting technique, and this xgboost is becoming more popular during these days due to the prediction accuracy of this XGBoost. So actually we can compare the performance of this XGBoost machine learning technique with some state-of-art machine learning techniques like deep learning techniques. So it's good to know about this XGBoost, and you can apply this technique in your machine learning task. So in order to demonstrate this XGBoost method, I'm going to use this arthritis dataset. So before doing that, you should have these packages installed in your machine. So if you haven't installed these packages, please install these packages before start anything. So then you can have this arthritis dataset. So I'm going to create a data frame using this arthritis data set using a data.table function using this data.table package. So you have to specify the data set name that you are going to use, and here this data set contains row names, and I don't need these row names in my analysis, so I'm going to drop these row names from my data set. Alright, so if I see the structure of this data set, you can see that there are actually there are 5 variables with 84 observations, and the first variable is ID, which might not be that useful to us, and the second variable is treatment, the third variable is sex. You can see these second and third variables are categorical variables, and the third one is age, and our fourth one is improved. So here I'm going to do a binary classification using XGBoost. So my dependent variable will be improved, and other variables will be my independent variables. So as you mentioned earlier, this ID will not add anything useful to my classification method. So I am going to drop that ID variable from my data set. To do that, type dataset name equals again dataset name, and type this square bracket, after that type comma, and since I need to remove this ID from my dataset, type negative inside this function C. You can specify the variable that you are going to remove, which is ID. Yes, there's a typo here, so it should be data S like this. Alright, so if you type this structure function again, str function, now you can see that now this dataset has only 4 variables, which is excluded. Now you can see this ID is excluded from the dataset. So sometimes it is very problematic to use these new categorical variables like treatment and sex as it is. So in that case, you have to encode these categorical variables using a dummy encoding method or something like one-hot encoding. So I'm going to use this one-hot encoding to denote these variables as using the one-hot encoding method. So to do that type, so my new dataset name will be data underscore 1h, that means one hot, is equal, I'm going to use this one hot package, one hot function, which is coming from this ML tools package. Inside this, type as dot data dot table, as dot data dot table, and type the data set name or the data set object and press enter. And now if you see the structure of the data set, you will see of this data one hot, you will see now they have created two columns to represent the two categories of the treatment, which is treatment underscore placebo, and the other one is treatment underscore treated. You can see they have done the same thing for the sex variable also. They have used this one hot encoding method to store the sex and sex equals female and sex equals male using two separate variables. After that, I'm going to create the design matrix because in this xgboost function that I'm going to use to create this xgboost machine learning technique is required to have a data frame, I mean a design matrix to represent the independent variables. So to do that, I'm going to use, first I'm going to define this design matrix using s underscore matrix and type sparse dot model dot matrix. This function can be used to create a design matrix for you using the independent variables. So my dependent variable here is improved and type tilde, and I'm going to use all the other variables as my independent variables. So type dot to denote that, and the dataset name is equals to data one hot. So this is how we have to specify your model in order to define your design matrix using this sparse.model.matrix. So first you have to type your dependent variable, then type tilde. After that you have to specify the independent variables that you are going to use. So since I'm going to use all my other variables as independent variables, I just simply type dot. But if you are using only a set of independent variables to create this design matrix, then you have to specify those variables separately. Alright. And there's one more thing that I need to do. I need to type square brackets and type comma, then -1. This implies, because if you see this, so before that I will demonstrate you how this design matrix looks like. So if you run this code and if you just use this head function to just see the first 5 observations of this data, you will see there is an intercept column which is added to the design matrix by using this sparse.model.matrix. So actually I don't need this intercept variable to my data set. So in order to remove this intercept variable, what I'm going to do is type square brackets, then type comma, then type -1. So by doing this, you can just remove the first column of your design matrix. So you can see now if you run this code and head of this matrix, now you can see there is no intercept column of this s underscore matrix. Okay. So now I'm going to define my response variable or my target variable. So if you see how many levels are there in this improved variable, you can see there are 3 levels, and since I'm going to do the binary classification, I'm going to specify my desired target level as marked, and all the other two so basically what I'm going to do is I'm going to define this marked as 1 and all the other two columns, all the other two labels as 0. So to do that, what I'm going to do is I'm going to use this 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 code, which is data s. First type your dataset name. After that, type the variable that you are going to specify, which is improved equals mark. So if you type like this, and if you use the table function to see how these two columns looks like, you will see that, or you can use the cbyte function like this, out and data is dollar improved. Now you can see that, so here you can see this marked is labeled as 3 and none is labeled as 1 and some is labeled as 2. Okay, so you can see based on this cbyte function, now all the observations which is labeled as 2 and 1 is coded as 0, and you can see all the rows which is coded as 3 initially has coded as 1. So now you can see that using this code I have converted this into a function which is initially had 2 levels to a binary variable. Alright, so now I have actually created my all independent variables using a design matrix and my dependent variable using a binary variable. So now what I'm going to do is I'm going to create this boosting classifier using xgboost method, xgboost boost function. So first type xgboost, then you have to specify your design matrix using data equals. So you can specify the design matrix here like this, is because my design matrix is s underscore matrix. Then type comma. After that you have to specify your target variable or your response variable using label parameter. So my target variable is out, and then you need to specify this max depth. I mean this boosting also a tree based method, so you need to specify the depth of each tree that you are going to grow. So I'm going to specify it as 4 and then you have to specify the learning rate of this function, which is you have to specify any number between 0 and 1. So I'm going to specify it as 0.8 as my learning rate. Then I'm going to choose how many rounds, that means how many trees that I'm going to grow for this. So first I'm going to grow 100 trees. Then you need to specify the objective function. So here my objective function is, since I'm going to do a binary classification, my objective function is binary logistic, binary colon logistic, like this. Okay. So if you want to know more details about this function, what you can do is you can use the help page of this xgboost like this. So it will provide you a detailed explanation about all of these parameters in this xgboost function. So if I run this code, you can see now you can see the training error for each and every iteration. So actually the one more cool thing that you can have based on these tree-based methods is that these tree-based methods you can use as a variable selection technique, because if you use these tree-based methods will give you some details about which variables are the most important in terms of this classification method. So in order to obtain that variable importance, I'm going to use this variable importance equal, and I'm going to use this xgboost function in this xgboost package. Inside that, first we have to specify your model. So my model is equals to pst, because this model name should be equal to your xgboost model name. Then I'm going to define my features. So feature names, feature underscore names is equal to the column names of my design matrix, like this. Now I can have this xgb.plot function, xgb.plot dot importance, and inside this you can have this importance matrix. You have to define this importance underscore matrix as the variable that you have specified earlier, which is importance. So if you run this code, now you can see the most important variable is age, and the second most important variable is the treatment with respect to placebo, and the third most important variable is sex. And you can see there's when you consider these three variables, there's a big difference between this treatment and age in terms of the importance. So basically we can see the age is the most important variable based on this data set. And now I'm going to identify how well this boosting method has worked. So to that I'm going to predict my response variable using this predict function, like this. So first I am going to type my xgboost data frame or my xgboost object, then type the design matrix, because here I didn't classify my data set into training and testing. So if you have done that, then you have to specify here as your variables as your testing variables. So press enter here. Yeah, there's a mistake over here, should be matrix. Then you can have a two-way table. So before doing that, you have if you see these predicted values like this, these predicted values are probabilities. So now you need to convert these probabilities into a categorical variable. So to do that, I can use this if simple if else statement like this. If else predicted is greater than 0.5, you can specify it as 1, else it is 0. Okay, so now you can create a two-way table like this. Table, inside that you can have this probability or prob, and the other variable is out, which is your response variable. So now you can see it has classified. So now basically we have 9 observations which is incorrectly classified. So the overall classification rate is around 9 divided by 84, I guess, because we have a total of 84 observations. So the overall classification error is 84. Sorry, 9 divided by 84. So this is how you can use this XGBoost algorithm to XGBoost function to create this XGBoost machine learning technique. So here, if you want, you can define this max depth and ETA using cross validation, and also in order to improve the result, you can have this validation set approach. That means you can have this k-fold cross validation, and you can train this data set based on the training set. Then you can test the data set using the testing set. So that will improve your result. So in my next video, I'm going to show you how this simple model can be improved using cross validation. Thank you.